Hey, this video installment is going to cover cleaning of aircraft carburetors. So once you have finished disassembling your carburetor, now it's time to clean it up so that you can properly do an inspection of the carburetor for damage and wear. So this one here, you can see that we have a lot of corrosion and rust staining inside the bowl. So of course we'll need to clean that up. And you'll see the same thing evident on a lot of the smaller parts, like the accelerator pump has rusted around that spring, and we saw that during disassembly. So the main thing you have to remember when cleaning the carburetor is that you want to start with the least aggressive method first, and work your way up from there. We don't want to start with something really aggressive that will cause damage to the carburetor. So here are some examples that I've laid out. We have your typical steel wire brush. I don't want to start with this. If I just start scrubbing the carburetor, yes, it will clean it up, and it will clean it up fast. But the way this works is these metal bristles are scratching and gnawing at the material and removing material with it. So any coatings I have that may be on some of these parts, you can see this throttle valve has this plating on it to protect it. If I just hit this with a wire brush, it'll clean up the dirt, but it's also going to take away that coating. I don't want that. We have something a little bit less aggressive. We call this Scotch Brite, and it comes in different colors, and that goes along with how aggressive they are. This may still be a little bit too aggressive for some parts. And then we also have sandpaper. Again, sandpaper, it's gnawing at that material, taking away the dirt, but also damaging any platings you have. So this may not be the best choice either. So where does that leave us? Well, I like to use an ultrasonic cleaner. So we can put our parts, submerge them in this cleaning bath. This is just simple green diluted with water. And then we turn this on for about 30 minutes, and we can also add a little bit of heat to it. And that part's going to sit there and be attacked by this ultrasonic cleaner, and all the dirt and grime and rust and corrosion is going to fall away from the carburetor, leaving clean parts behind. So the way an ultrasonic cleaner works is it sends these high frequency sound waves into the part, and that creates this cavitation of the cleaning solution in there, makes a lot of little bubbles in it, and when those bubbles break, that provides some energy or shocks the part that you're cleaning. So when that happens, it's basically tapping at the buildup or corrosion you have on there and helping to break it free from the part and basically shake it off. And that, mixed with the heat that this can introduce into the part, makes for a really effective cleaner. So it won't remove everything. If you have some severe corrosion or a severe hardened buildup, say like carbon, it may take several rinses, and even then it might not get it all off, but it is a great first step. So an example of that is these inlet fuel strainers. The one pictured on the right has gone through that cleaning bath. The one on the left has not. So you can see, without scratching or removing any material, we have a nice polished and clean filter. Again, without much effort at all. So that's kind of what you want to do. I want to start with the least aggressive. The ultrasonic cleaner does a great job there. And if that doesn't remove it, I can maybe visit Scotch Brite or even just a stronger chemical to attack and remove that buildup. Now, please remember, whatever you see here, whatever I'm talking about and showing you that I'm using, may not be acceptable for the specific carburetor you're working on. You always want to use cleaning methods that are approved by the manufacturer for the carburetor. And there are certain components that we can't expose to, let's say, that ultrasonic cleaner or chemicals. Any rubber parts or even the float itself, we shouldn't put that in the ultrasonic cleaner because the chemicals, the simple green, may destroy them or harm them. Okay, so different materials may require different methods of cleaning, But no matter what, we want to start with the least aggressive method first. And if that doesn't work, keep stepping it up slowly until we can remove that grime and buildup. And again, keep moving up in aggression as far as the manufacturer will allow. Okay, if you have something that is seriously corroded or damaged, and taking it to the wire brush on on a stand to remove that corrosion, at that point you may want to consider replacing the part if it's that bad or if it takes that much effort to remove the damage. When using something like the ultrasonic cleaner, you have to be vigilant of what coatings you have, not just the material types. This is a good example. You see how this carburetor body is painted black? Well, this side over here was dipped in the ultrasonic cleaner, and while it cleaned the corrosion off from the inside of the carb, you can see it also ruined the paint. I can sit here and flake off the paint. So this carburetor will have to be stripped and repainted as a result. But if that's what it takes to properly remove the corrosion and make sure that it's clean inside, so be it. But just remember, if you care about the finishes, you really need to pay attention to how much heat you expose it to, how long you expose it to the cleaning process, and what you're using to clean it. Okay, I've also intentionally cleaned up this discharge nozzle using a steel wire brush just to show you the damage it causes. So if you look closely, you'll see all of those scratches in the brass. It did shine it up and it looks better, but we don't want all of those scratches. Those scratches are, again, gouges in the material. And although it did clean it up, removing material is not the way I want to go about this. The same would happen if, say, I used sandpaper. I'll show you what happens there. Doing this, like I said, removes material, it scratches it up, leaves all these imperfections in the surface of the material, and actually makes it more likely to degrade again faster. So you're creating more surface area with all those little digs in the material, and it makes it want to rust or corrode quicker in the next go around because you've removed that smooth surface that keeps that from intruding into it, and it's going to allow water and dirt and debris and everything else to want to stick to this a lot easier. So I want to avoid those methods of cleaning. Also, here's a piece of wire. Again, do not use this to clean out holes or passages. You will deform them and change the way flow occurs through them. I don't have a way to show you at this time, but even the smallest change to the size or shape of these openings will drastically alter the flow pattern of fuel or air through it. Okay, same with all these passages. Don't go jamming this through your idle jet or even your air bleed passages and all that. Use a source of compressed air. And it doesn't have to be extreme. Like here, I have this tool to inflate a basketball, but I can use it like a air pump. So hard to do with one hand, but I can aim it at that passage and then plunge this down and shoot some air through and make sure that it's clear. Okay, and of course, if needed, you could use something more aggressive like shop air and adjust the output pressure using a pressure regulator. But yep, that's where we are. Make sure everything's clean. Do not submerge gaskets or anything else that's non-metal in the cleaning solvent. Be cautious of your finishes. You don't want to disintegrate paint, then you don't need to subject it to the chemicals. Try to limit where you put it or apply it. You also don't have to submerge the entire part, and that goes along with what I just said. If you want to do more localized cleaning, you can put some cleaning agent in a container like this and then dip a brush into it and then work on one singular area. Okay? But the moral of the story is use the least aggressive method first and then go from there. It's important to protect yourself as well. So far in this video, we've been talking about how to protect the parts, but not so much about how to protect yourself. I've already discussed wearing gloves, goggles, ear protection, and all of that, but another big one is protecting your breathing, uh, your respiratory. So, anytime you're using a chemical of any type, you should first pull up the MSDS or Material Safety Data Sheet, which I have an example for Simple Green pulled up here, and read through it. A lot of times, we as mechanics get into the routine of smelling chemicals every day, and it becoming kind of the norm. But you have to think about the long game here. Repeated exposure to these chemicals, breathing it in day after day, can lead to some serious health issues, cancer, respiratory issues such as asthma, skin sensitivity from touching chemicals all the time. It adds up. So please, before you expose yourself to any chemicals, read through the MSDS to identify any risks that are involved with using this product and how to properly protect yourself. Plus, the MSDS will give you critical information like what to do if it catches on fire, or if I do start to see side effects, what should I do to correct them? Lots of important information in this document that you don't want to have to try to find after something has gone wrong. You want it now, before something happens, as a preventative measure. Okay, now that we've covered the cleaning process, I just want to show you what the manual says here. So it basically tells you to use a recommended carb cleaner that the manufacturer suggests to clean the parts. Do not expose non-metal parts to carb cleaner. I kind of mentioned that. So like the float, any gaskets, O-rings, anything that's not metal should not be put in the cleaner because it's likely to not react well. Okay, here's something else important. Your carburetor has a lot of small passages and orifices, like the main jet and the idle jet, things of that nature. You don't want to use a hard piece of wire or something to clean out those passages, because that metal wire that you run through there can deform the hole or the passage and alter the way fuel flows through it. So if I force a wire through a jet, basically count it as being garbage now. You have to throw that away and get a new one, because you can't be 100% sure that it's still the factory size. That wire may have altered that hole, even if it's slightly, even if you can't see a difference. You'd be surprised how dings, dents, scratches, deformations in the metal can alter the flow of fuel and air through a carburetor and really change its performance. So if I need to clean that out, I can use compressed air after soaking in a cleaner. So compressed air won't alter the material itself, but it can be a good tool to blow debris out of a passageway.